So for the project, I handled primarily sorting the data and handling the hypothesis testing. So here are some of the assumptions we made when doing the hypothesis testing. We assumed the sample is randomly selected since it was all taken from one box of the same trail mix, but each weight was individually made. We assume that the population is normally distributed, both through the central limit theorem and also by using the distribution graph, which is shown in this PowerPoint. It appears to be normally distributed. And there is the formula I used when calculating the t-value, since we were only trying to find the left-handed side of the t-test. We used the formula for that to find that t-value. Here are some of the test statistics that were found after gathering the data. Our sample size was 30. Our sample mean was 35.8 grams. The sample standard deviation was 0.45 grams. The calculated t-value from the previous formula was 10.43. Our degrees of freedom was 29, and the actual listed weight was 35 grams. And this is just showing both the t-value, the critical t-value from the textbook, and also visually shows it on a graph of the red area being the region of rejection, including the critical t-value, and then the green line being our calculated t-value from the gathered sample. After testing our hypothesis, we found that since region rejection was anything below negative 1.699 and our t-value was 10.43, we failed to reject the null hypothesis. And our p-value was approximately equal to 1, so if replicated, it should be very similar to what we found if this was replicated multiple times using different samples. Here we just kind of go over some of the ways that it could be expanded upon. For example, if you took samples from, instead of one specific box, but for example you bought multiple packages of trail mix at multiple different stores, that's another way you could get a better random sample. Or you could use it as a comparison point between, for example, you buy one brand of trail mix, another brand, and maybe like 3 brands total, and you compare each of their weights to see how accurate each one is to the actual listed weight, to get an idea of how it varies across different brands. So overall, I feel like this project was very useful for understanding how hypothesis testing works. I feel like having an actual project where you're required to come up with your own hypothesis, do the testing yourself, and having that like real world application is a very useful means of teaching, because in a lot of classes you may use these ideas but you're not exactly sure how you can actually apply them in the real world until you start either getting to more advanced classes or you actually start working. So it's a bit more obvious, but I still feel like having a project like this is a good way to get people used to what they should expect when it comes to actually if they ever have to use hypothesis testing or any of these tests in the real world. I feel like it's a good way to get people prepared for that. And overall, I have to say it's been a very interesting and pretty enjoyable project. I've definitely enjoyed going through it. So, thank you.